Question 1, Part A. Use the table of standard integrals to find the exact value of the integral of dx over the square root of 16 minus x squared from x equals 0 to x equals 2. The technique I'm going to apply is to convert the integrand into the standard form k times f dash of x over the square root of 1 minus f of x all squared dx, where k is some non-zero constant. And this is based on the first derivative with respect to x of the inverse sine of f of x by the chain rule is equal to f dash of x over the square root of 1 minus f of x all squared. Now the question is to find the definite integral from x equals 0 to x equals 2 of 1 over the square root of 16 minus x squared dx. So we want this 16 to turn into the number 1. I'm going to do that by factorising 16 out from the expression 16 minus x squared. And in doing so, we get the integral from x equals 0 to x equals 2 of 1 over the square root of 16 multiplied by 1 minus x over 4 all squared. Notice that's in brackets. Now the 16 can be taken outside of the surd, so notice it's a convenient square number. And we get the integral from x equals 0 to x equals 2 of 1 over 4 times the square root of 1 minus x over 4 squared dx, which equals the integral from x equals 0 to x equals 2 of 1/4 over the square root of 1 minus x over 4 squared dx. So at this point, we have the standard form, f dash of x over the square root of 1 minus f of x all squared. So our f of x is x over 4, and the first derivative of x over 4 is 1 over 4. And at this point, we can integrate. So we have inverse sine of x over 4 from x equals 0 to x equals 2. And applying the limits of integration, that equals the inverse sine of 1 over 2, which is a simplification of 2 over 4, minus the inverse sine of 0, and that equals pi over 6.